This video is intended to introduce the new automated test system framework. It seems reasonable to review existing automated test system architectures employed by various industries. The dedicated automated test solution architecture is the classical. Here software or application performs an interface to the user, instruments control, sequence of test execution cases, and report generation. This software application has both advantages and disadvantages. Its advantage is the fastest test execution because the application's overhead is minimal. A disadvantage is that it is the most expensive solution and its modifications are difficult and expensive. Disadvantages of the dedicated test solution architecture are impeding the development of complex tests, especially where debugging and tuning become very time-consuming. Because of this, National Instruments, or NI, came up with Test Stand Automated Test Solution Architecture. The test stand is the test management system, which performs user interface, instrument control, and report generation. Its advantages are scalability, better code or driver reuse, and much lower demand for programmers' qualifications. Disadvantages are: the test report is native to the test stand and difficult to customize, the user interface is not really user-friendly, and there is still need for a programmer involvement. To overcome most of these issues, we developed the NewTS Automated Test Solution Architecture, which fundamentally differs from previous architectures. In this solution, the communication to a specific instrument is delegated to the corresponding soft panel while the test management component, called the execution engine, remains responsible for the test case configuration, error management, and reports generation. The NewTS architecture has the following advantages: programmers' involvement is greatly reduced or minimized, test case development efforts minimized, standard user interface across projects, the process of learning the test software is simplified, licenses for LabVIEW and/or test stand eliminated. The instrument's soft panels replicate the appearance and functionalities of the physical instrument as much as it is practical. This approach greatly reduces the learning curve of the soft panel operation. Now let's review the NewTS execution engine functionalities in real life. Upon clicking on the execution engine icon, the application will start with its login window. There are 3 levels of login: operator, engineer, and administrator. The operator login level allows them to start a test, pause the test, and view graphs and images. As you can see, pages, test editor, MEM number, MEM street, test report, and SWST settings are disabled. We can change the login level to the engineer. In this case, the application practically restarted: the test editor page, the memory numeric page, the memory string page, the test report page, and the system settings page become enabled. If we log in as administrators, we also get access to the admin page from where users and passwords are being managed. Let's go back to the operator's login and demonstrate the test execution. As you can see, the instruments are being reloaded. After relaunching and checking that the instrument is good, its soft panel closes. This is how we configured it. To start the test, we have to press the Start button and enter a serial number into the slot 1 field. The execution engine application allows to run up to 8 UUTs simultaneously. If needed, we can increase this number per customer request. But what it means, in reality, we need a similar number of test report templates. Now it is time to enter the serial number and press the Done button. After just 28 seconds, the complete test of a is done. Now we are in the process of generating the test report and converting it into PDF format. If we log in as the operator, to see the test report we have to go to the NewTS framework folder, UUT folder, and open the folder with the same name as our UUT. The test reports are located in the Reports folder. Here we can locate our latest report and open it. As it was mentioned before, the NewTS framework allows to create arbitrary test reports to meet the customer-specific requirements. The test report template is the MS Word document. There are tags, which will be replaced with test data. Such tags are login name, login level, serial number, test results, and the test data stored in the numeric memory locations, memory 1 and memory 1pf. The execution engine application provides up to 384 numeric memory locations which can be used in the test report. We will demonstrate how to create a new part number or UUT and test cases in the NewTS execution engine. To do this, we have to log in as engineer to have access to the test editor page and the system settings if needed. After entering an operator's name and password, we can log in. The execution engine will open the last used part number and load all involved instrument soft panels. In this demo, we use NI USB 6343 DAQ. Now we have to go to the test editor page. Please note that the letter M next to any control denotes that particular control has a user menu. The part number selector has its user menu. Add new part number, remove part number, edit UUT description, refresh test configuration, open test file, sortist file. It is obvious that we need to select the Add New Part Number menu item. The Add New Part Number dialog window will open. To proceed, we have to fill both fields. The new part number was created. If there is a need to verify that this is true, we have to go to the location of our UUTs and open just created folder, NewTS Video Demo folder. In such a folder, the files containing test cases, limits, report template, and reports folder are located. But, at the moment, we didn't create any test cases and limits. This is why here is the only testcases.cfg file. Now it is the time to create the test case. To do that, from the Test Case menu we have to select Add New Test Case. Let's create test case number 1 because we will have subtests 1.1 and 1.2. The dialog window, Add New Test Case, will open and we have to fill at least the parameter and description fields. Now we have to create another one, 1.1. Normally, the test case parameter and description should reflect your test procedure document such as ATP, as an example, to make navigation through test cases easier. So, we just created another test case, but it does not contain any instructions for the instrument's soft panel. The test case configuration list box contains the list of all instructions to be sent to instrument's soft panels to execute the particular test case. The test configuration list box contains all test cases needed for the particular UUT test. The instrument /function selector contains the list of all instruments soft panels installed. Since we are going to use the NI USB 6343, we have to select its soft panel from the list. As well as multiple execution engine specific functions, such as abort on failure, operator's message on fail, operator's message on pass, jump on fail, and many other functions. The local jump on fail allows to jump within the current test case, while the jump on fail or jump on pass allows continuing the test execution in another test case. There is also a set of operators messages, delays, timers, and more. These functions allow us to configure, practically, any test execution flow. The argument 1 selector has 4 items: set instrument control value in the instrument's soft panel, get the instrument indicator value from the instrument's soft panel, read instrument indicator value from the instrument's soft panel, and wait for an instrument indicator will reach a specified value. Each instrument has its own list of controls which can be selected from argument 2. The USB 6343 has a list of controls. Next, we will select argument 2 AI.physical.channel and for argument 3 select NI USB 5343/AI0. It is much easier to configure the instrument when its soft panel is open. To do this, right-click on the instrument's /function selector, and from its menu list select Open Instrument. To demonstrate that the execution engine communicates to the soft panel properly, on the soft panel let's change the analog input physical channel to AI2. Now let's click the Execute Instruction button and verify that the physical channel control on the soft panel is changed to AI0. Now we can add this instruction to the test case configuration table. Somehow I clicked on the Add Instruction button twice. We will go to the test case configuration table, select the needed line, and from the menu select Delete Instruction Item. Now we have to save the test case. Please note that next to the Save Test Case button there is a rectangular LED indicator. In the case of any changes in the test case configuration table, the LED indicator will be off. When a test case is saved, the content of the test configuration table is compared to the saved value, and in the positive result, the indicator turns light green, thus indicating that the save was successful. The next step in the analog input configuration is to set the sample mode. Let's select finite samples, and in the soft panel, we will set the sample mode into continuous one. And again press the Execute Instruction button and verify that the sample mode in the soft panel is set to finite. And press the Add Instruction button. One more thing, if any instruction line is selected in the test case configuration table and we add a new instruction, it will add it before selection or after selection. It is defined by the checkbox right above the Add Instruction button. If nothing is selected in the test case configuration table, the new instruction will be added to the bottom of the table. The logical approach to creating the set of instructions in the execution engine is to perform all configurations in the soft panel, check if it works, and then replicate it in the execution engine. Next, we have to set the terminal configuration control, then min-max input limits sampling rate, and number of samples. Setting up the input terminal configuration. Setting up the maximum input voltage limit. Setting up the minimum input voltage limit. Setting up the sample rate. Setting up the number of samples to be acquired. If there is a need to change something, just double-click the desired instruction line to transfer it to the instruction function, argument 1, 2, and 3. Make desired changes and click the Update Instruction button. Please note that the Update Instruction function works only if the instruction line in the test case configuration table is made. Now we have completed configuring the analog input, and next, we have to configure the analog output. This process is practically identical to the previously described analog input configuration. Setting up the analog output physical channel. Setting up the analog output generation mode. Setting up the analog output sample mode. Setting up the analog output clock source. Setting up the maximum output voltage limit. Setting up the minimum output voltage limit. Setting up the analog output sampling rate. Setting up the analog output number of samples. We can select a single instruction or group of instructions and execute that selection. Or, execute the whole test case. But before doing that, we have to add at the beginning of the test case the delay between instructions. It is the time between instructions being sent to the soft panel. Now let's execute the whole test case. If we go to the soft panel analog input page, we can press the button Measure and the measurement results, about 7 volts, will be displayed. We have to add the measure instruction to our test case. And, also, add some delay to ensure that all data is acquired. As the next step, we have to bring acquired measurements to the test engine and evaluate whether our test passed or failed. To do that, we will select for the argument one item, get, and have to configure limits to evaluate the test results. And, to be able to generate the test report, we have to save this data to what we call numeric memory. The numeric memory actually is the set of numeric controls to hold the measurement data. To do that, we have to select the function, save number data to memory, and add it to the test case. Now we are done and ready to run the whole test case to make sure that everything works correctly and check the memory page. The MEM1 displays a value of 7.002p where the suffix p indicates that the test passed. If the test would fail, the suffix would be f. Now let's go to the main page. This is what an operator will see. If we expand our tree, we will see the test 1.1 which we just configure. Before starting the test, let's skip the report because, at the moment, we don't have the test report template. Let's press the Start button. The UUT serial numbers input window will open. Since we have only a single slot, the slot 1 input control will be enabled. Let's enter the UUT serial number and press the button Done. The system message indicator will show instructions being sent to the soft panel and from there to the instrument. As you see, the test case passed. Now let's talk about the test report. First, the reports are located in the UUT folder of the NewTS framework main folder and further in the individual test folder. The execution engine generates a report from a report template. Let's copy the existing report file to our NewTS video demo folder and open this file. Let's modify the report template per our demo test. The execution engine generates a report from a report template. Let's copy the existing report file to our NewTS video demo folder and open this file. Let's modify the report template per our demo test. Please note that because we ran the whole test from the Start button, the reports folders were created even though we chose to skip the test report. Let's uncheck the Skip Report item in the main menu and start the test again. At the test completion, the Word test report file will be updated, but because we don't have yet the test case 1.2, that section will be not populated. In a little while the PDF file will be created and the Word file deleted. However, we have the option to keep MS Word report. Let's check that box. Let's go to the test editor page. For the conversation's sake, if we double-click on the row of the test configuration table, the X symbol will appear, indicating that this test case will be excluded from the test execution. To remove that symbol, just double-click again. Let's create another test case 1.2. This will demonstrate how to import a test case from another UUT test. In the part hashtag selector, select the NI ISB 6343 demo multislot, where the desired test case is already configured. Let's select test case 1.2 and from the test case configuration table menu select the item Copy All. It will put the contents of the table into a virtual clipboard. Now we have to come back to our NewTS video demo. Select the test case 1.2, go to the test case configuration table, and in its menu select the item Paste. As you see in this test case, the analog output is set to 5 volts. There is also the analog input configuration, which is no longer needed since it is the same as in the test case 1.1, so we can safely delete it. Press the Start button and enter the serial number. We will see the test progress in the test case configuration table. When the whole test is completed, the report is being generated. This is how we create test cases in the NewTS execution engine. As you see, the test editor page provides the all tools needed to create and debug test cases. While we using the execute all function, we can set the pause and the execution will stop immediately. 10. We can step through the test case using the Next button or just unpause the execution. If we set this pause button, which becomes active after the test starts, the current test case will finish its execution and then stop. This function is very useful for retesting any test cases or modifying the test case parameters. The user, also, can run development tools like Execute All, Execute Selected, or edit the test case scope. The Emergency Stop button executes the emergency set of instructions located on the SYST settings communication page. These instructions are sent to the soft panel directly. In addition to all these, we have the Options page, where we can skip or not skip the report, convert the Word test report to a PDF file or not, perform an export of a Word report to the PDF document, using the LabVIEW exporting tools OD using the command line. Select the report template type, either field will be marked as bookmarks or tags. The report, also, may contain images. If that option is checked, the images will be imported into the test report. There are many more options and functionalities built into the NewTS execution engine and instrument soft panels, but all these are out of scope in this demo video. Thank you for watching this video. Your professional opinion is very valuable for us. We would appreciate your comments.